Today we're going to be going over kinematics. Before we dive into it, what exactly is kinematics? Well, a quick Google search will tell you kinematics is the branch of mechanics concerned with the motion of objects without reference to the forces which cause the motion. Basically, when we work with kinematics, we want to find out how far an object moves, how fast it moves, or how fast it accelerates. To do this, we have three general equations. In these equations, there are 5 different variables: displacement, initial velocity, final velocity, acceleration, and time. In a way, these variables are like pieces of a puzzle, where using the equations, you can put it all together to see the big picture. Let's tackle a sample problem to show how to solve for an object's displacement. The car accelerates from a stop at 4 meters per second squared. Calculate how far it has traveled after 10 seconds. Let's see what this looks like. Let's see which variables we have and which one we're solving for. Try deciding now where each variable goes. Great! From the problem, we know acceleration, initial velocity, and time. This leaves us 2 unknown variables, displacement and final velocity. So which equation should we use? That's right, the problem is asking for displacement, and this equation lets us plug in each of our values to find the total ending displacement. Now that we have our equation, all we have to do is plug in our values and solve. And once we plug in our values, we can see that the car's traveled 50 meters in 10 seconds. Now let's see a more interesting problem in 2 dimensions now. A baseball player hits a baseball at an angle of 30 degrees. When the ball leaves the bat, it has a speed of 50 meters per second. How far does the ball travel? Let's watch what's happening visually. Well, let's start as we did with our last one, defining which variables we know for sure from the problem. Try filling it out now. So from the looks of it, we only have our initial velocity, so how can we solve this? Well, for 2D motion, we can consider the x and y components of velocity and acceleration separately, as their own problems. Let's take our ball, hit at a 30-degree angle, and use vector addition to change it into 2 vectors, one completely vertical and one completely horizontal. You can imagine this as the ball being hit straight up and then falling down, or the ball traveling straight horizontally instead. So now that we've divided our problem into 2 separate ones, we know our initial velocities are 50 cosine 30 and 50 sine 30 for the x and y directions respectively. Can you figure out the rest? Well, we know in the y direction, the acceleration is going to be negative 9.8 meters per second squared because it's acceleration due to gravity. And we also know that since he's hitting it up and it falls back down to the ground, the overall displacement in the y direction is going to be 0. For the x direction, we know it's not accelerating because there's no net force acting on it in the x direction. So our final velocity is going to be the same as our initial velocity. So to solve this, we're going to need to solve for x, the total displacement. And to do that, we're going to need to know how long the ball is in the air for. So let's examine our y component. Can we solve for time using these variables? Which equation should we use? That's right, it's the same as our last one, so let's just plug in all our variables. And once we do that, we can solve our equation. Just need to factor out a t, and then we get 2 answers for this equation. So if we have 2 answers, how do we know which one to use? Well, t equals 0 would correspond to when the ball is hit by the bat, so t equals 5 would correspond to the point where the ball hits the ground. So we can disregard t equals 0 since the answer wouldn't make sense, and use t equals 5 for the time the ball is in the air for. Now we can plug in our time for the time in the y direction and the x direction too. Since there's no y displacement, then all our displacement must be in the x direction, so total displacement is equal to x displacement. Now that we have our time, we can plug into the same equation we've been using to find our total x displacement. So we can plug in all our variables now and solve our equation. So we just solve, and it looks like our answer is 125 times the square root of 3 meters. So the ball is landed 125 rad 3 meters away from where the batter hit it.